Good day. I am Janus Isayar Kiambao.
And I am Dennis Agustin.
And I'm Michelangelo Gonzalez.
And this is our group for the Group Report 2. So the Group Report 2 consists of all of our learnings in Orientation to Chemical Engineering, CH100. And now, without further ado, this is our Group Report 2.
Chemical engineering is one of the broad branches of engineering that is concerned with the production, design, transportation, and transfer of energy and materials. Chemical engineers harness raw materials and use the sciences and mathematics to synthesize a product or products that are used on a daily basis.
CH100, or Orientation to Chemical Engineering, has taught us much about chemical engineering as a profession and as a career. From what chemical engineering is, its place as one of the branches of engineering, and how science and mathematics are applied to create materials. Its humble beginnings and how it became one of the most popular branches of engineering, its role and place in Philippine society, and its apparent future.
Chemical engineering sets itself apart from the other branches of engineering as it is often cited as a universal engineering profession, as a chemical engineer's technical and scientific mastery covers both the physical and biological sciences as well as mathematics. A chemical engineer uses these branches to create or synthesize new products or convert energy from one form to another, as is the case with power plants, so as to better the lives of people who would consume such products on a daily basis. Although chemical engineering is universal, it goes hand in hand with the other engineering majors, as all these engineering majors work together to power contemporary human society. Human society in the 21st century is impossible without chemical engineering working hand in hand with civil, electrical, electronics, mechanical, industrial, and all the other forms of engineering. Chemical engineering would provide the means to supply society with consumables such as food, cosmetics, medicine, water, and energy. This is not possible if factories and power plants are not built in a way that utilizes each part to create such products and utilities, which are only possible if civil engineers and industrial engineers create a viable factory or power plant for production. The machines that would be used to create these consumables would only be there if mechanical engineers are put in charge of creating the machinery necessary to do so. Electricity, which powers all of contemporary human society, which are created in various types of power plants, would only be possible if not for the electronics and electrical engineers, who would be responsible for drawing electricity from the power plants to urban areas.
Chemical engineering itself is also a broad field. There are different types of chemical engineers, whose professions can vary from production to quality analysis to research and development and to sales. Some chemical engineers are involved with the production and synthesis of material for mass production. These involve the production of food, petroleum, medicine, and everyday objects. The way that these materials are created and synthesized from various material differ from each other. This process uses different methods to create the end product that would be consumed en masse by people. Some chemical engineers are involved with the quality analysis, that is, they are involved with keeping in check the quality of the products being manufactured in mass. These chemical engineers check if the products which are being mass produced retain the standard quality that the manufacturer has set for their products. Some chemical engineers are involved with the research and development. These engineers concern themselves with testing various materials and chemicals to create new materials or replace already existing materials, which can be made more easily and are less likely to have a negative impact to the environment. Some chemical engineers are involved with sales. These chemical engineers would explain the product and or chemicals that they manufacture to investors and buyers so that they may encourage these people to buy them and use this product and or chemicals in the production of other more useful materials. In the seminar entitled The New Chemical Engineer, Transitioning from Academe to the Industry, introduced to us two chemical engineers from two distinct fields of chemical engineering. The first being Engineer Jonathan Aquino, who is a chemical engineer which is involved in the production of materials, specifically glass working for the San Miguel Yamamura Asia Corporation, and the other being Engineer Melody Garcia, who is a chemical engineer involved with sales working for Simrise Inc.
The Industrial Revolution paved the way for chemical engineering to be a dominant force in the engineering profession. It is at this time where products began to be mass-produced due to innovations in machinery and the introduction of electricity as a power source to power machines more effectively than human hands. Prior to the Industrial Revolution, there exists a forerunner of the discipline in the form of Nicolas Leblanc and the Leblanc process. George E. Davis, a British chemical consultant, is widely known as the father of chemical engineering due to the publication of his book, A Handbook of Chemical Engineering. In 1915, Arthur D. Little paved the way for the basis of the classification of chemical engineering with the formulation of unit operations, which proved to be one of the turning points for the chemical engineering profession. At the turn of the century, process system engineering paved the way for innovations in the petrochemical industry and in biomedical engineering. The 1950s saw a surge in innovations in polymer science, which paved the way for the age of plastics. With the passage of time, environmental protection and industrial safety were given much more focus. As of the present, advancements in the Human Genome Project and its completion allowed for more advancements not only to chemical engineering profession, but in genetics and genetic engineering.
As chemical engineering has become such a phenomenon in society, particularly in the Philippines, provisions were settled to fully define the chemical engineering profession. The signing of RA 9297 or the Chemical Engineering Law of the Philippines, which was signed in 2004, regulated the practice of chemical engineering in the country. The law provides articles about the definition of the chemical engineering profession, the creation of the Regulatory Board of Chemical Engineers in the Philippines, the licensure examination and registration of chemical engineers, and the scope of practice of a chemical engineer in the country were laid down in the said Republic Act. Provisions for the amendment of the said Republic were submitted in the form of Comprehensive Chemical Engineering Law, which was filed as House Bill number 8625. In line with the chemical engineering profession, the Philippine Institute of Chemical Engineers, PICHE, formulated a code ethics in which a chemical engineer must stand by as a professional. Provisions in the Code of Ethics include how a chemical engineer should act professionally when at work, like not jeopardizing the production of a material or avoiding credit grabbing. These provisions were published in the Official Gazette of the Philippines.
Orientation to chemical engineering as a course opened up our eyes to the broadness of the chemical engineering profession. Preconceived notions like chemical engineers focused only on chemistry and not on the other branches nor sciences nor on sales were given much enlightenment during the course. As a profession, chemical engineering has undergone radical changes to suit the radical changes that were also commonplace during the tumultuous history of humanity during the past centuries. From simple unit operations involving the conversion of one material to create another material, to the utilization of newer types of fuels to replace the fossil fuels which negatively impact the environment, the chemical engineering profession has reinvented itself time and time again. The limits of the chemical engineering profession are defined by the number of chemicals that can be utilized in creating useful materials for everyday use. Boundless. as newer innovations like concrete being able to absorb water, to the testing of new discovered molecules to determine its possible uses in everyday life, the future of the chemical engineering profession is as broad as the horizon. The seminar, the interview with the chemical engineer, and the plant visit has greatly helped us learn to appreciate more the profession that we put ourselves into. It is now up to us, chemical engineering students, to make the chemical engineering profession that we chose worthwhile.